Hello everyone, welcome to the first video in this series, which will cover a full end-to-end software development and delivery using Azure DevOps. So the first video is introduction and high-level overview of DevOps. So in this video, the first we are going to review the series outline for other videos. Then we will understand what is the current business and technical challenges that most of the companies, if not all the companies, they are suffering now. Then we will have a quick overview about DevOps and some of the metrics for measuring the DevOps and the statistics based on some study in the market from many companies. After that, we will give an real example of high performance DevOps companies and why we consider them as a high performance and how this affecting their software development and delivery. Then we will have a quick overview about software development and lifecycle and its activities, as it is very important to bring this in the same picture so we can remember them. Then I will give an overview about continuous delivery principles and practices. After that, I will give a quick overview to continuous integration. As I explained before, it's very important to review all this concept and bring them so to make sure that everyone on the same page. Then I will give a quick overview to continuous deployment. And at the end, I will explain the difference between build tasks and release or deployment tasks. So we can distinguish between the difference between them, because I have seen many times that people are confused. For example, they might run automated UI testing as a part of the build, while should be part of the deployment. So we will just see the difference between them and where is the boundaries for build and deployment tasks. But let me give you a quick introduction about myself and my background. My name is Mohammed Radwan. I'm a developer technologies MVP and principal DevOps. So I have been doing software development for more than 15 years now. I worked with many projects, helped many customers, heavily participated in the community, worked in many countries for different projects. It is very important to review the content of the series, so we can understand what is the content of each video, because this will help to understand where you are and where the videos that you can find to cover the topics that you are interested more. So this part will be repeated in each video. The more questions you ask, the more we all learn. So I will encourage you, don't hesitate. If you have a comment or question, please leave it in the comment of the video, because this will raise the discussion, which will bring more values for everyone. The first video is introduction and high-level overview of DevOps. In the second view, abstract overview of end-to-end software development and delivery using Azure DevOps. In this video, I'm not going to talk vertically about different Azure services. Instead, I will give an horizontal overview about how to use Azure DevOps as an end-to-end solution. Then I will talk about different configuration and setting for the Azure DevOps settings, like organization settings, the difference between different types of user, like stakeholders, basic user, and so on. In the third video, I'm going to talk about Agile and Scrum planning using Azure Ports. In this video, we are going to see how to manage project. So for example, manage requirement, prioritize the backlog, manage the sprint, the starting date, the ending date, capacity planning, a cumulative flow diagram, and different topics of Agile and Scrum using Azure Ports. In the fourth video, managing source code with Git using Azure repos, we will see different usage of Git with Azure repos. For example, how to create new repo, how to clone the repo, creating branch, merging code, setting branch policies, pull request, and so on. In the fifth video, build automation and continuous integration using Azure pipelines. We will see how to build a pipeline for the build automation, compiling the code, running the unit test using the visual tasks or the YAML. In the sixth video, we are going to see managing artifact repositories like NuGet, npm, Maven using Azure Artifacts. We will see how to use Artifact to manage our third-party libraries for different technology. In the seventh video, release management and continuous deployment using Azure pipelines, we are going to see release management, how to build a different environment, talking about the pre and post deployment, managing configuration, and the release gates, so different topic for release management. And the eighth video and the last is test planning with manual testing and exploratory testing using Azure test plans. In this video, we are going to explain how to verify the application. We will run exploratory testing, create test case, execute test case using test runners, test configuration, and so on. So for those they don't know about the Fortune 500, there is a magazine in the US where it lists the top 500 companies based on the fiscal year revenue. So 50% of these companies has gone. It's not exist. They has been replaced by company that use the technology to deliver the customer value faster, better, and cheaper. If anyone remember or knows the Blockbuster company, which was one of the top companies that renting movies in the US, in 2004 it has about 10,000 stores, 5,000 of them only in the US. It has revenue in billions. This company has been kicked out of the market and replaced by a startup company called Netflix back in 2010 in that time. In 2010, Blockbuster has big problem, and after a couple of years, it's completely gone. As we can see, it is not just that this company affecting some of the revenue for the competitor. It leads to that this company completely vanish. This is why technology is changing the way that we're doing our business. It's changing the way that we deliver our services for our end user, how we deliver the products. What is the value for Blockbuster for 10,000 stores in the US while Netflix delivers the movies using an app on the TV for everyone in his home? And for those companies that they don't understand the digital disruption that's happening, they will face the same fate. This is why we usually say that the current 500 today will face the same challenge tomorrow if they don't understand the digital disruption and how to use the technology to get innovation. So this is why usually I will say business and technical innovation, it is not an optional anymore. It is the only way to survive. As we saw, it is not just affecting that the companies may get less revenue, it just may lead to the company to be completely out of the market. Since we understand the importance of the innovation, we need to understand that innovation needs to be delivered quickly to the end user, at the same time reliable. So it's very important to give the end user quickly the value, and at the same time the value or the services is available, is secured, it doesn't have many problems. So because at the end, if I deliver quickly without reliability, then I lose the brand, I lose the customers, I lose and all of that. And because we are living in a technology driven world, so developers are the heart of the company innovations. And it's very important to provide the tool for the developers that increase their productivity and accelerate the collaboration between them, so it can help for bringing more innovation to deliver the value quickly with high reliability. DevOps. If we ask what is DevOps, probably we will get different answer or different definition about DevOps. So for some people, it's all about collaboration between development and operation. Some other is infrastructure as code, and for other, it's all about automation, while others believe it's a culture change. Small deployment or frequently deployment, Kanban for operation, or it's a job title.
So, what is DevOps? DevOps, none of the previous. DevOps is not continuous integration or not continuous deployment. Of course, all of that is part of the DevOps, but DevOps is more wide than this. So it is all about the union or the integration between people, process, and products to deliver continuous value to the end user. So it just look at the complete end-to-end for the software development and delivery. And this is the main idea of the DevOps. Deliver quickly with a high reliability for the end user.
There is a study which includes around 27,000 to 30,000 companies to analyze their adoption of DevOps practices and where people are. The study done by two organizations. One of them is DORA, or DevOps Research and Assessment, which is non-profit organization and provide academic research. And the second one is Puppet, which is a software company that provide a configuration management tool. And the numbers is almost close to each other. So let's look at some of the results. The study has many useful information, but let's take one of the important metrics, which is frequency of deployment in production. So they found in 2014 the following value for frequency of deployment in production. In 2015, they found that the frequency of deployment has been increased with these values. So the increase was around 17% from 2014 to 2015, 40% in 2016, and around 60% in 2017. So as we can see, more companies are going to more frequency of deployment in production. So if we look at the study and to see the company at the top, they found that it deploy 200 times more frequently than the company at the bottom. For example, if the company at the top is deployed in production every 1 day, then the company at the bottom will deploy every 200 days in production. Also, the company at the top, it has faster lead time with 2,555, more than the company at the bottom. The lead time is the time or the duration between working on the requirement from the beginning until deploying this requirement to production. So for example, if it's require 1 hour from the beginning to the end to complete one requirement, the company at the top will take 1 hour, then the company at the bottom will take 2,500 hours. So what they found that the companies that implement high performance DevOps, first, they exceed 2 times their profit, market share, and productivity goals. They don't fail. And if they fail less 7 times of the company at the bottom. And they recover 2,600 faster from failure. I can spend all the day talking about this point. The main idea of recovering from failure, let's say, for example, after they deployed the new version in production, the application is not working properly, and they need to fix that. Or maybe the current version of the application has a problem in production and the service is not available. So if the company at the top will fix the problem in 1 hour, the company at the bottom will fix the problem after 2,600 hours. And why this? The main idea that the company at the top, they are embrace the failure. They are not afraid of the failure, fail fast. They fail many times and they learn from their failure. They understand how to master this failure. So, but for company at the bottom, they keep fighting to prevent the failure. They put all the effort to prevent the failure from happen. They put many documentation like the disaster recovery, many documents planning for dealing with the failure. And when the failure happen, they bring all the documents, try to fix that, and they are struggling to fix the problem. And it takes time to fix the problem because they are not ready. But for the other company, again, they don't prevent the failure. They keep measuring the failure rate and the mean time to detect, the mean time to recover, and this measure which shows them if they are on the right track or not. And after the preventing the failure, they have less failure rate. This is why some companies created some failure frameworks to, like Netflix created Chaos Monkey, where it's an open source on GitHub where they can make failure for the system because their system it doesn't fail, so they need to make that in purpose so they can train on how to interact or deal with the failure. So if we look at the innovation with oversight, so top performance DevOps companies spend more time in innovation and less time keeping the lights on. As we have more time because we don't fail. And if we fail, we recover very fast. So this time that other company used to recover from failure and just covering all this problem, the top companies, they just use this time in innovation, in new work, and this bring more value to the end user and gives the end user the value very quickly. Real example of DevOps. So is there any real story so we can see? Yes, if we look at Amazon, it deploys to production every 11.6 seconds. Maximum deployment in a single hour around 10,000 times. And there is a great session by Amazon team explaining their journey for the continuous delivery. Also here, there is some other example. Amazon is not the only company. So we can see here by frequency of deployment, we have Amazon for 1,000, more than 1,000 deployment per day. Netflix, the same. HubSpot, 300. Etsy, 50 deployment per day. IMVU, 50. Microsoft, Google, Mozilla, 2 to 3 weeks for new release. Let's quick review the software development lifecycle and its activities. So as we have the SDLC, while it looks sequential, but in the modern software engineering development, they are not sequential. For example, code, build, and test, they usually happen at the same time when we're talking about Agile and Scrum. But to just explain the idea, this is the main stages, and in each stage we have different practices and activities. For example, in the planning, we have the requirement management, prioritize the backlog, and the project planning, and so on. In the code, we have the code development, we have the version control, the branch and merge, and all these practices. In the build, we have continuous integration, we run the code test, the code quality, the build status. In the package, we create the package from the artifact, which is the output of the build, and then preparing the package and storing the package on the package repository. In the test, we verify the application by running test plan, test execution, and determine the test result. In the release management, we manage to deploy the application, we pick the package from the package repository and start deploying the application to the destination. In the configuration management, this where we manage infrastructure as a code, configuration as a code, and it is part of the source control as well. So all our code, either infrastructure or configuration, is under source control. And in the monitor, we monitor the application performance and usage and the experience to understand how our user or end user using our application. Continuous delivery principle and practices. This is one of the best book about continuous delivery, and it has great 8 principles and 4 practices about continuous delivery. So let's look at the 8 principles. The first one is the process for releasing and deploying software must be repeatable and reliable. It's very important to be able to run this process again and again. Automate everything. everything can be automated. I just have concern about the keyword everything, because sometimes people, they want to automate anything. Like for example, they don't have a manual task and then they start thinking how we can automate something which is not exist in the beginning. And this is not correct. I mean, the main idea for automate everything, this answer or this reply for people when they say this can't be automated. No, everything can be automated, and we are going to automate everything. But first, we want to make sure that it is repetitive. So you go first for the manual, and then if it this repeated, then we start thinking of the automation. And if it's repeated again, then the automation is a solution. But don't think of automation at the beginning without having a repetitive task. If something difficult or painful, do it more often. Again, I could spend the whole day talking about this. And this is the main reason for most of the companies that they implement high performance DevOps, that they take less time to recover from failure, because they usually using this principle. Because if this is painful, if this is failure, don't afraid of it. Just welcome the failure, embrace the failure, and just learn from it, take it as a train, and you will find a way to make it very easy to you and make it, something is not painful anymore. Keep everything in source control. This is very important. Source control, it is not for our application source code only, it's for everything. But again, I have a concern about everything, as I explained before. So in many cases, we found people do put under source control some files which is not belong to the source control. So for example, you don't put the binary under source control. You don't put the minifying file under source control. So any file that processed by the tool and produced by automation, it is not under source control. We only keep the file under source control where we edit them. But again, in some cases, some of the files we don't edit because we don't, for example, we don't use infrastructure as a code. So we don't have our infrastructure as a code, so we will not keep them. No, the main idea that everything you edit it's either configuration or settings or infrastructure, it should be under source control. So whatever you are going to change, it must be transformed into code, and this code under source control. But anything that is generated or it's an output of a build process or compiling, or you don't keep it under source control. For generation, for example, any generated files, it is not under source control. Done means released. When we're talking about done, it means released. So when we're talking about continuous deployment, continuous delivery, it means delivery in production. Build the quality in. Again, quality not at the end, but we're starting from the beginning. Everybody has a responsibility for the release process. It is not the responsibility of the operation team, it is the responsibility of everyone of the team. The last one, improve continuously. We need to look at continuously improving that using the Kaizen. Okay, look at the 4 practices of the continuous delivery. Build the binary ones. This is very important. So it is not like every time you want to deploy to the environment, then you trigger the build and create the binary. This is why we have the package repository, where we build once and store our package in the package repository and then deploy this to different environments. So we build once and deploy multiple times. Use precisely the same mechanism to deploy to every environment. This is very important because in many cases, some companies, they just deploy for all environment in one way, but when they deploy to production, they're using other way. So we must trust our deployment mechanism, and we have the same mechanism. Smoke test your deployment. I must verify that my deployment is correct. If anything fail, stop the line. Again, don't cheat the process. Just make sure that if it is painful, do it more often, and you will learn, you will train how to deal with the failure, and then the failure and the painful will not be painful anymore. So let's have a quick overview to continuous integration. Why does the code become not integrated? So if we have many developers working on the same code base, this is probably will have not integrated. But first, let's understand what does it mean by the code is not integrated. The first is, which is the minimum of the code is integrated, means that no compile time error. The second one, which is an optional, we usually calling that quality gates, that no unit test fail. So all test cases are passed. The third one, code coverage for unit test exceeds certain percentage. So for example, we identify that code coverage should be not less than 60%. Also, we can have that there is no violation for code quality, like maintainability, security, naming convention, portability, and many, all of that identifying the integration of the code. And it's vary from company to other based on how you would like to keep your source code is integrated. And to understand more about that, let's see what is the case if we have a build without continuous integration. So let's say that we have our developers and we agree that before we commit any code in the source control, first we need to run all the code. First, we need to run all the unit tests and all tests must pass. The second, that code coverage must be greater than 60%. And the third task, that code quality all method must has lines of code less than 10 lines. So this is my specification or my requirements for the code to be integrated. So if Safe is a developer that writing the code and he commit his code, and Safe should run the tasks as I explained. The same for Laura. When she completed the code and she want to commit, and she should also run that. But for me, I don't know if they run that or not. No one knows if they run or not. This is why they might run. Maybe they forgot, maybe they have a problem. I don't know. And in this case, their code will not be integrated, and this will lead that one of them or maybe both of them will commit a code which is not integrated and doesn't satisfy my quality gates or specification. So let's see the scenario with continuous integration. When I have a continuous integration, if Safe is a developer and he wants to commit his code, once he tries to do that, this will not commit the code, but instead it will trigger a build server, which will run all the tasks, run the unit tests, the code coverage, the code quality, and review them and make sure that they passed. If they passed, then the code will be committed. If they don't, then the build will fail and it will prevent the code from committing to the source code. The same will happen with Laura if she wants to commit the code. Trigger the build run, and run all the specification and the verification, the checklist, and pass. This will commit. If it's fail, it will prevent the code. This is why if any one of them or both of them run or not, I don't care, because at the end, my source code is guarded by the build server. The build server working as a safeguard for the repository or for the source code, and my source code always integrated according to my specification about the code. So let's have a quick overview about continuous deployment. The developer starts writing code, which usually a high-level language like C#, for example, and then they start kick the build or start building the application, and the build will produce the artifacts, which usually is the transformation of the source code into, if this is a desktop application, it will be machine language, assembly for .NET, for example, or if this is web application, this could be minifying JavaScript and CSS. Sometimes it could be bundling JavaScript. The main idea of the first step of the build is to transform the high-level language into a language destination specification. And of course, the build has many tasks as we explain, like run the unit test, for example, and code quality and so on. And usually the last task of the build is to, once we have, as we explained, the build is creating the artifacts. As we have the artifacts, the last task is to package this artifact. And the main idea of the package artifacts is to organize these artifacts into package. Just it's matter of organizing these artifacts in a way, boxing them to be easy for distributing or redistributing. Once I have the package, then I start provisioning the destination, creating the environment and preparing the environment. And after that, I pick the package and then deploying the package. This was in the old. But now the best practices recommended that before I doing the provision and the deployment, I should store the package in the storage. And this is exactly what we are going to use the package repository. So once I store the package, and if we remember the four practices of the continuous delivery, build once and deploy multiple times, this is exactly what we will do when we store our package, because we are going to store the package in the store. Now we deploy to the dev environment. If I want to deploy the QA or the pre-production, then I will just pick the same binary, which is the same package from the storage, and start deploying that, of course, provisioning the environment first and then deploying that. So build once, deploy multiple times. To move from one environment to another, usually it required approval. And we have two types of approval, the pre and post deployment approval. So the pre-deployment approval, it's like sign in to receive, and the post deployment, it is like sign off for completion. So for example, if we are in the dev environment and after deploying to the dev environment and everything is fine, then it's required some of the developer or maybe the dev manager, according to the process, that to sign off that the development complete. Once this completed, then in the next stage, which is the QA, then the QA needs to have a pre-deployment approval. So they sign in that they receive the build to start working on the test. Once the QA approve in, then the deployment start. And of course, this will start by provisioning, pick the package from the storage, deploy the application. Then after that, run automated acceptance test and maybe run some manual test at the end. And once it's completed, then the next step is a post-deployment approval, which means that the QA completed the work and they sign off. And the same for the next stage. There is a pre-deployment approval. Once it's approved, then the environment will provision and deploy. If this is a pre-production, then there is a post-deployment, which means that we sign off and ready for production, and so on until it reach the production, which means that there is no post-deployment, as the application will stay and will not go out, as there is no next stage. So let's look in details for the release management steps for one stage, starting from the pre-approval deployment and the post-approval deployment. We will take the QA as an example. The stages start by that the QA receiving the notification for approving that the development completed and they are ready to approve so the deployment can start. Once the QA approve, then the deployment start. And the first step is to provisioning the environment. This part of the infrastructure as a code. So usually the deployment or release management picks the source code for the infrastructure from the source control and start creating the environment or provisioning the environment based on the infrastructure instructions which exist in the code. Once the environment is completed, then the next step is pick the configuration as code and start configuring the environment. And this is the post configuration. For example, if provisioning the environment is a virtual machine which has Windows server, and then configuring the environment is enable IIS Windows feature, or maybe enable ASP.NET on, or maybe open port on the machine. So a post configuration is needed for the environment, but we need to provision the environment first. Once this happens, the release management to start pick up the application from the repository, from the storage, then start distribute or installing that on the environment. Once it's completed, then the post configuration for the application. Maybe we need to create some data, lookups data, all this kind that needed for the application. Once this completed, then the release management will start creating the testing data because to run an automated UI test, you will need data. For example, if you want to test that the registration is successfully, then you need to have a username, a password, the email to you can try that with different scenario. So the first step in running the automated test is creating the test data, then running the automated test. Once this passed, it means that the environment ready for manual test. Then the QA go and start running the manual test. Once they approve the manual test, everything is fine. They sign the stage, which means that the application is passed all the test. And this means they sign off, which means that this will trigger the notification for the next stage approval, of course, usually by email. So this is the release pipeline steps. And as we saw, the release pipeline doesn't include creating artifacts or package or store package in the repository, but release pipeline is responsible for running automated acceptance tests, and creating the package and all these tasks is part of the build, not the release. So let's look in more details about different environments and the process for moving the package between one environment to another, which we calling promoting the package. We usually have different environments, and this could be different from one organization to another. So this is just an example. The first environment, which is the development environment. This is usually the environment where the developers start verifying that the development is complete. We have two approaches here. The first is that consider each developer machine is a developer environment, or in some cases, it may require having a development server. The main point that if it is required to have a development server, don't make it as a bottleneck, because this is the last step before moving to the next stage. And if you have one development server, then this will make a bottleneck, because, for example, if another developer want to deploy to the dev server, but it's not available because it's occupied by another one, this will make a problem. So we should have like one-to-one relationship between developers and development environment. And this is not only for development environment, but for every environment. We should not have a bottleneck that the environment is not available. You may be asking now how we can have many environments. If you remember, we agreed that we provision the environment on the fly, and once we complete it, we can tear down. So once the development is complete, then the approver here is the developer. The developer sign off that he complete the development. Once he did that, then the package is deployed to the testing environment. And this will be for what we call the feature test. This testing environment is very important, and the feature test process is very important, especially if you don't implement feature flag. Feature flag is another topic. We will talk about it in another videos, but for now, just remember, it is very important to have separate and isolated environment for feature test before we merging the code. Once the QA approve that the feature is completed and it's working fine, then we'll deploy the package to the QA environment. In the QA environment, this will be incrementing this feature with other completed feature, so the QA team can work as an end-to-end. So here is an integration testing between different features before promoting that to the next stage. Once this completed and the QA approved, this will lead to promoting the package to the next environment, which usually is the pre-production. In the pre-production, we usually try to have some of the real data from production, of course, after we clearing the sensitive data, so we can verify the application with the actual data, which is very important. Then once the pre-production and the release managers approve this package, then the package will be deployed to the production. Let's look at that from a different angle to make more sense. When the developer is starting committing the code to the source control will trigger the build automation. And if you remember, the build automation will start creating the artifact, the package, and all this. And maybe the unit testing will fail, which will bring the feedback to the developer that they need to fix. Once the developer fixes that and start committing the code again, and in this time, the unit testing passed, all my quality gates passed, which will trigger creating the artifacts, packaging the artifact, and store the package in the repository. Once this happens, this will trigger the deployment. By triggering the deployment pipeline, the deployment start by pick up the package from the repository and start provision the environment, deploy the package to the environment, and start run automated acceptance test. If the test fail, then this will get a feedback for the developer. So the developer now needs to fix the problem. Then after the developer fix, it goes through the steps from the beginning. Once the automated test has been accepted or has been passed, then it will wait for the approval from the QA to approve and sign off to promote the package to the next stage. Once they approve, again, it could be approved automatically. Once they approve, it will promote the package to the user acceptance testing environment, and it will wait again for the approval to be deployed to production. Once this happens, here is the gate for the approval. This will deploy the package to the production. So now let's review and make sure that we can distinguish between the build and release task, or the build pipeline and the release pipeline. So in the build, we usually compile the application or bundle and minifications, any form of transforming the source code into machine-specific or a destination-specific language. For example, bundle and minification. The bundle here usually for the JavaScript. So in the development time, I will need all the JavaScript in a readable form. If I have 100 JavaScript where I can edit them as a developer, I don't need to distribute them to the server as a 20 file. So in the bundle, it will just making one file that contain all the JavaScript code, for example, because it doesn't need it for the server that host the application, for example. The same for the minification. We don't need the space and carriage return and comments and all of that. The steps of transforming the source code into a destination specification. After that, versioning the application, run unit test, calculate code coverage for the unit test, run code analysis, static analysis, code smell, measure technical debt, code smells, calculate and run code metrics, depth of inheritance, cyclomatic metrics, different code quality for my source code, create the code documentation, package artifact, and store the package in the repository. So this is the last step of the build, is to store the package in the repository usually, but we don't run acceptance test. We don't provision environment as a part of the build. If we go for the release tasks or the release pipeline, the first is spin and provision new environment. Configure the environment for the desired state, because we would like to have this configuration like enable IIS, enable ASP.NET, or maybe installing some component using the Chocolate framework, for example. Then pick up the package and start deploying to the environment. Install the package on the environment, configure the package on the environment or the application on the environment. Create testing data, run integration and acceptance test, roll back to the previous version if we needed, promote deployment to next environment, move database from production to pre-production in cases we want. And of course, part of the process of the pipeline is to clear the sensitive data or remove the sensitive data, send the email or maybe SMS or Twitter, or maybe even post to a Facebook group. So this is the release pipeline tasks. At the end, I would like to thank you for watching the video. Please, if you have any question or comment, don't hesitate to ask. You can visit my blog, which will appear on the link on the screen now, or click on the related video, which is appear on the screen as well.